I was peeping on you. Look, you're doing some combinatoric stuff and coding up the solution to check. So I hope that went well. Today's a general relativity day. I'm just getting set up for that right now. That Puika Pro's nice. So yeah, this hey Saint Cult. Yeah, so it's been basically us learning differential geometry, and it's not been easy, but chapter 7, we've been having an easier time with the questions so far, at least. So hopefully today also goes well. Fembox hate. I think I'm good to go. We can just hop right into it. Oh, I'm on push to talk, aren't I? I need to fix that. Voice activity. Hey, we've been talking about trying to do a third coding competition together for a while, though. The issue is always like where we get the questions from. Yeah, I need to get back into the coding swing of things, but I definitely would. Did I? Oh, wait. Yes,
Hey,
I did.
Doc.
Hey, Fembucks. How's your Saturday going?
Good. I went out to lunch with some friends, and then I came home and took a nap.
Oh, nice. That sounds nice.
So pretty good.
That's quite a key there, Slim. I do know that Euler has like friend requests. Hey, Aditya. What kind of food was it?
Mexican.
Ooh, I love that.
Yeah, we go to Mexican a lot. Yeah, we like it.
I'm friends with Jed, apparently. Prangle. Okay. Taylor series. I can, but not right now. Yeah, I'm sorry. That's gonna be in like two hours. Sounds good. Saying called. Pringles was taken. Fair enough. Okay. So we're still in chapter 7. Last time we were kind of doing well. Oh, I should bring up the solution key. We left off on, or we finished number 10 last time, as far as I remember. So I'll bring in number 11 to the Excalibur.
As I recall, last time we started strong, and then we ended a little less strong.
Yeah. Pringles also your sustenance when you code. I used to love Pringles as a kid. I'm not too big on them anymore though. You a fan of any particular chips, Fembox?
I think Pringles were better when I was a kid, and I think Doritos were better too. I think they've changed the manufacturing process or something, probably to save money. They just don't seem like they're. But it might just because I got older too. But they don't seem as good as they used to.
Yeah,
I think
I
now
haven't had them as an adult, to be honest.
I just like plain corn chips, really.
That's fair. Those are good.
Yeah.
It's the kind of sickness that fuels you to finish a coding problem. Okay. Hey, Eldridge. And hey, ADS. I'm sure you were fine. Balaji chips.
Pringles are cool, aren't they? From a mathematical point of view, because they're like a saddle.
Oh,
curve
true.
or
Yeah.
yeah.
Okay, I probably grabbed this one because it has an S with it.
Oh yeah, that's supposed to mean easy.
Yeah. So for the warp drive space-time example in 7.4, show that at every point along the curve x sub s of t, the forward velocity of the ship lies inside the forward light cone. So
This is our light cone. They're saying.
yeah, I think that makes up the kind of border of the light cone, like the slopes of that line. Maybe I should have grabbed more of the example. I think there's some that I chopped off because I didn't think it was needed at the time, but I feel like maybe we do need it. Did they actually solve for x sub s? No. We might not need to, but um well actually we don't need to worry about x sub s, we just need to worry about the forward velocity.
Yeah.
Um So presumably if we can show like u dot u is -1, that's a marker that it's like time-like. Because if it's 0, it's null, and if it's something else, it's space-like, I think. Oh, nice, ADS. If you ever have any questions about streaming for me too, I'm always happy to help with stuff like that. Let's get the ship. So what is... Hey, Hamiltonian dynamics. Presumably we need to do something with that.
VST is the velocity associated with the curve.
I guess that's a scalar though. I guess it kind of depends on what kind of stream you'd want to do, ADS, but I guess the general advice is try to find a part of it that you enjoy and can be shared easily and focus on that. Um, I feel like the straightforward questions are getting less straightforward the deeper we get.
Yeah.
Because I don't know how to begin finding the forward velocity. Because it seems like it's just kind of, things are defined kind of generically.
Yeah, I mean, should we look back at section 5.2? That's what I'm looking at.
I'm just kind of scrolling up before the example to see if they do something like this. But the chapter 5 might be what we want to look at, yeah. Um, oh, okay, so I did just realize that the Y and Z components are always 0. So that does simplify it a little bit to be just the time and X component that we have to worry about.
Okay.
And presumably the X component of the 4 velocity is the V sub S. What would the time component be?
Is that where we have to come up with a parameterization?
Maybe?
Maybe not. Maybe not.
How much backseating is allowed? We're definitely open to having some, like, maybe just don't give the entire solution away, but like especially right now when we're stuck and not sure how to proceed, like a hint is definitely welcome. The hard part about it is that you don't really, like, or when people just kind of like come in and start trying to give help, they don't always know like how the book presents things or what we do and don't know. So it tends to be a little bit difficult for that reason. But if you have a thought, please do feel free to share it.
They're talking about the 4 velocity on page 84.
Right.
And they did say something about proper time.
The 4 velocity is gamma comma gamma times velocity. Like the 3 velocity. So presumably the 3 velocity is the V sub S. If we can figure out what gamma is, then maybe we would be in business.
Is it just 1 over 1 minus 1 over square root 1 minus V squared again?
I don't know. We need, you're right, the tangent to the curve, that's what the velocity is. That makes sense. I I would think what you said is right, Finbox. I just get nervous because that chapter was just on flat space time and we got this weird thing, and so I wonder
Yeah.
if at some point there was like a single equation they said for how to figure this out that I'm forgetting now. Maybe not, though. I'm kind of speedrunning through chapter 6, just seeing if I see any U's or anything.
Oh, wait. At every point along the curve XST. Oh, we haven't used that.
Yeah, it's just kind of a generic function as far as I can tell. Like, they never actually say what XS is.
Well, no, it's inside RS. RS is x minus XST squared plus y squared plus z squared. So if we let x equal XST, then RS is always 0, isn't it? I hadn't realized that. I think that's what they're telling us.
Wait, isn't that the distance from the origin? That's how I was reading their definition of R.
I thought RS was like a distance away from the light.
Oh, maybe it's distance traveled along the line. Maybe XS. Oh, yeah, the X, Y, and Z are kind of the arbitrary points, I guess.
Did you?
It's distance away from the particle. I don't think we need a safe word for hints. I mean, if you have a hint to give, I said it's okay. Okay, if we did just say that U is equal to 1 over... Wait. Is gamma the reciprocal or... I always forget this. Is it 1 over the square root or is it just the square root? I think it's 1 over the square root. Hey, Ashu. Will this even work out to give us -1?
Yeah, I think it will. Because don't forget the negative on the time, the square of the time.
Thank you. They have a common denominator. Yeah, they already do have a common denominator. So yeah, that turned out to be -1. You're right. Yeah, okay. Hamiltonian dynamics, I think you're right. I think that's what I was afraid of with trying to do this, because I think that's something that we learned for the Minkowski metric, but this isn't. And so I don't know if it still applies is my issue. Like, I don't remember ever learning what you do if you don't have the Minkowski metric now.
I remember not ever learning that. You get it?
You remember?
I remember not learning that.
Oh, as in like you saw it but didn't learn it?
No, as in like I don't believe it was covered.
Okay.
Or if it was, it went right over my head.
Yeah, that's what I'm afraid of, because I remember that last week I there's an issue with like the dot product for for something, and I just completely skipped over that formula apparently, or it didn't sink in what it actually was. So that's what I'm afraid of is happening here. Find the tangent vector from the parameterization and use the normalization. But yeah, so I guess like for the x component, that seems like we're just going to call it dx sub s dt, but I have no clue what to do with the time component. Like, I feel like half the time they say they choose the time component so it is normalized. But I feel like the question is asking, show it is normalized. So we shouldn't just say it is. You're just saying it's 1? Oh, because it's parameterized in time. That's unnormalized. It's not really helpful if you just say the answer. We're trying to understand why. This isn't going to be actually what we call you, but I guess we need to figure out a way to normalize this. Find the constant because the forward velocity is c squared. And then for here, the book is doing things with c equals 1, so I'd expect to get... I mean, if it's time like, I expect to get -1 is the like desired result. But I feel like then I'm getting back to like that for the time component. So it would give the right answer, but well, no. Not, I don't know. Hey, Exotical. Why is the time component always 1? Careful. Oh, because the dot product is different. That's right. Uh,
Did you work something out?
well, I think, okay, yeah, I think I'm picking up what Hamiltonian dynamics is saying, or like, it's not as simple as u dot u, or u dot u is something more complicated because we have to worry about
Oh, the G metric.
yeah. Okay. So maybe, I assume we need to multiply things out to figure out what these coefficients are going to be. And then when we have mixed, like we're gonna have a dx dt in here. I assume we're gonna figure out a way to deal with that at some point. I forgot the f. Hey, physics explained. Plus dy squared plus dz squared. And then we should combine the dt's. Vs squared minus f squared. No. Times f squared minus 1 dt squared minus 2v1f dx dt.
VS.
Thank you. Plus dx squared plus dy squared plus dz squared. So when we have a mix of dx dt, how do we deal with that in the dot product again?
Last time we went backwards and we completed the square to get rid of it. But that's kind of going back the way we just came from. Or is it?
I mean, if we can figure out a way to factor that, that seems nice. But I guess wouldn't it just be the thing we already did? I don't know.
Yeah, we did one like that last week, remember? And you came up with the idea of like completing the square on it.
Yeah.
I remember. I guess, is it going to work?
Or do we, oh, maybe we just get another term in the dot product.
Oh, yeah. I guess so, because it's supposed to be a 4x4 matrix, right? That G matrix.
Yeah. So I think you're right, Hamiltonian dynamics. We're just very unsure of ourselves with this. So I'm especially unsure when it comes to all this subscript, superscript stuff, how it actually works. Because there's like a symmetry where there's dx dt, but also dt dx, and that's going to be weird for me when it comes to the how we're actually going to apply it to this dot product here. Oops, I didn't mean to do that. So are we taking this like candidate for you? Hey, good boy. Dotting it and figuring out how we have to adjust to get the normalization we want? I'm gonna say, and maybe I'm gonna call it V just to say it's like you, but not quite you yet. So the time component, I think we just take that as it is. I don't think we put a negative sign on it. Maybe V is a bad letter to use because we already use V sub S, but and then times 1 squared because time component times time component. Plus, and then we have a dx dt. Well, so it's going to be the same thing, so maybe I really don't know if I'm going to account for this right, but maybe 2 times to account for, we're going to have one thing for dxct and another thing for dt/dx, but I think it's symmetric. I hope.
I think so.
V sub s f. And then times 1 times v sub s. Plus v sub s squared. And I think that's it. Hey, Yesh. And we're going to set this equal to -1. Let's hope this works. Yeah, so we're basically doing dot products in curved space-time, and it's very weird. That's not how that factors. Wait, yes. Okay, yes, that is. If I add this one to the other side, this is... I don't know about this.
Yeah, I don't know what's going on.
I think this is the right thread to pull. We're just not doing it in the right way. Because this doesn't seem very meaningful, what's happening here. Okay, maybe this is one of the ones where I look at the first sentence of the solution key.
Yeah.
Okay. Chapter 7, number 11. Voltage should be multiplied by an overall constant. I still want to be sure what to do with it. Oh. Okay. So, okay, a part of this is the confusion with, like, this weird stuff that they're defining. R sub s is the distance away from the world line, but we're talking about the world line itself, so R sub s is 0.
Yeah, that's what I was saying before, but now does that even help us? What does that do?
Well, it means f is 1, so we don't have to worry about f.
Okay, f is 1.
Let's at least clean that piece up. Oh, no, not that. My cursor is nowhere near to that, and it's still just erasing it for fun. Okay. of that, get rid of that. Just get rid of the last line. Okay, and so I'm going to take a constant, call it b, and rather than going back through and fixing everything, I'm just going to say, ooh, well, maybe we do want to bring b all the way through. So we get a b there, and then a b times b vs there. And then a b squared there. Just delete that last line and rewrite it. B squared vs squared minus b squared plus 4 vs b squared vs plus b squared vs squared. I just realized that can be simplified. We have common terms here, don't we? Is that 6b squared vs squared minus b squared? We want b to make this minus 1? I guess we just solve it for b. I'm just checking through the work before, but I guess this is hopefully okay. Now that looks a little bit weird, cool. But does it work?
It's just got a 6 where we didn't have that 6 there before. Right?
Hamiltonian dynamics doesn't like to say that f equals 1. That's what the solution key said. On the world line of the ship, at least, f equals 1. So unless we're talking about outside the world line. So let's see if this... I guess I want to plug it back in and see if this actually works. The answer we're proposing for u, which if... I guess we're saying this is a proper answer because it would normalize to minus 1. Oops. And so if we were to go back through and do the dot product, theoretically, it should give us what we want. So vs squared minus 1 times 1 over 1 minus 6 vs squared plus, I guess, minus 2 vs. Did I get the minus sign? Oh.
Oh, this one?
Yes, did I make a mistake there? I think I did.
Know.
Because G should be the minus 2 vs, I think. Ugh. I think it should be a minus.
Oh, okay.
Which means that's a minus, which means this needs to change.
Just the 6 would be
Oh, a negative
a 6. So
2.
yeah.
Okay. That's a minus. And that's 2 times whatever we're getting. 2 v sub s. Then times the x, or times the time component times the x component. So I'm just going to do that multiplication now. And then we need the double x component. The double x component just has a 1, so it'll be plus v sub s squared over 1 plus 2 v sub s squared. Okay, let's see how this works out. They all have a common denominator. V sub s squared minus 1 minus 4 v sub s squared plus v sub s squared. You're not sure about the extra factor of 2? I think this is getting us -1. Yeah, I'm not sure about it either. My argument is that we're getting the same thing twice from this because there's a dx dt and a dt dx. So I was trying to account for that, but I really don't know what I'm doing with this thing, so I might be overcompensating. But this is -1 at least, so... I mean, maybe we did the math with the wrong thing, but... If we didn't have the 2 there, we're just going to get a... All the v sub s's will cancel out. Hey, Lucas. Maybe that's desirable, maybe not. I mean, we just get b equals 1, I think. I'm going to peek at the answer a little bit more.
Yeah.
Wait. This is the entire solution? What? They didn't do any dot products. Oh my god. Uh, okay. Well, what they said is that they took the dxct equation 7.26. They said since f
Yeah.
equals oh you read it? Okay.
Yeah, I saw what they did. Yeah, they set f to 1 and they split it into two slopes and said our vs is bounded by them. I mean, all right, that's what we had to do.
Did
I didn't
they?
know we had to do that.
They didn't really say that. I guess we know that x sub s is time like. That's how we were supposed to know that. Or they don't really say that either.
Yeah, maybe we should have just looked at the picture more. Maybe it was because that picture from this problem, they kind of zoomed in on it and
Um,
they didn't say what the okay, so if okay, if we're on the curve xst, that means r is 0. And I think if r is 0, then I think that means our spaceship is not in the gray area. It's on, I think it's on the black line, right? Like right in the middle of that picture, I think. Right? I think
the
that's the world line we're on, right?
yeah, that's the word line of the ship.
And so if we're on that world line, I guess that means all the little instantaneous cones, light cones on that world line are going to go like up slope 1 and down slope 1 from whatever our whatever that slope is, I guess. Like add 1 and subtract 1, and
Oh,
that's how you
okay.
get little
Yeah.
cones on that line.
Okay. I think you're right.
I don't know. Yeah, I don't know how to turn that into a 4 vector. Yeah, I don't know how to turn it into a 4 vector.
I don't know, this feels almost circular to me where like it always lies inside the forward light cone because we've said it does. That's kind of how it's coming off to me. Hey, Everton. Um, how much math do you need in order to stay in touch with the newest known problems in their proofs? If you want to stay in touch with all of them, that's probably more math than any one human is gonna know. But you need to go pretty deep into one area of math. You don't need like a high level degree to stay in touch with it, I guess. But um, it'd be a pretty long time of studying. Okay, I don't know how I feel about that problem. It feels a little bit weird. I don't know if the stuff we did is valid or not, but maybe just go to the next one. Number 12. Oh, not another one about this. I mean, maybe we can do this. It should be some type of integral. You know, maybe I'm going to shift the question out so it's right next to the screenshot here. I wouldn't be opposed to just skipping over this one, but if I can think of an idea, then, or if either of us can, then we can go for it.
It's talking about coordinate time.
How much ship time elapses on a trip between stations? Like coordinate time t. What is, okay. I don't know what that means. Is time
We talked about coordinate bases.
yeah, and I didn't understand that.
No, what was the difference between coordinate bases and orthonormal bases?
I still don't know.
I don't know how to do this one.
Okay.
I don't know how to do this one.
Yeah, I thought I had an idea until
I think
you
you're
pointed
right.
out the
It's
coordinate
probably
time. I don't know what that means. Is it like the time that one of the people on the space station would measure? Who knows?
yeah, maybe people on the ship versus people on the not on the ship.
Yeah, maybe. In a certain space-time geometry, the metric is that weird-looking thing. And the second part looks spherical. Like this part, we looked at that in chapter 2.
Yeah, that does look familiar. And the other ones have a common factor, extra factor of 1 minus AR squared squared.
Yeah. Calculate the proper distance along a radial line from the center r equals 0 to a coordinate radius r equals r. I've seen it, Ritesh. So I assume we're holding time, theta, and phi all constant for that.
Okay. Yeah, we could try that.
I don't know what to call this. I guess s is equal to the integral of ds squared. But here it's going to be...
Just integral of ds.
Oh, thank you. So we're square rooting that.
Actually, there was a squared on it, so...
Oh, you're right. Ritesh, it's just questions from a textbook. It's not a test. Okay, and then that seems straightforward. Hey, mouse. Well, this is weird. This is a negative distance, depending on what r is. If r is more than 1, I guess, or something like that. Well, it depends on what a is also. So this could very easily become negative at some point. I assume that's okay.
Wait a sec now. This is reminding me of 7.6.
Seven 7.6. Like the example?
Yeah. Let me see what they did there. The distance from the center to a surface along a line, theta is constant, phi is constant. Okay. Okay, so...
I think we just did the same thing.
Yeah, you did the same thing, right? So... Okay.
This is a book on general relativity. It's not for an actual class. We're just reading it for enjoyment. So the answer we got looks a little weird, but I think it's just what we get. For part B, it looks like we're not going to need to worry about time at all until the last part. Next time a physics exam, we could do that. The area, so they gave a little formula for dA. Okay, so wait, why did I write B equals? The area equals integral dA, and dA is root the relevant parts of G multiplied and square rooted. So r squared times sine squared square root r sine theta. R is a constant. Times double integral d theta d phi, and r should be big R. And this is physics, so theta is 0 to pi, phi is 0 to 2 pi. So this should just be a normal. If R is constant,
Don't you need a, no, wait a second. Don't you need a 1 plus sine squared here? Where this is?
you're right, they both have an R squared. Wait, not necessarily 1 plus sine.
Or the square root of 1 plus sine squared? Is that what it would be?
So I definitely forgot that it's like it's r squared times r squared sine squared, but I don't know that we need a 1 plus. So I think it's just big R squared, because we get r to the 4th times sine squared, and then we square root it.
Ah, you're right, because it's, yeah, okay. Okay, sounds good. Sounds good.
Okay. Not what I meant to do.
That's nice, because that makes the dimensions come out looking nicer.
Oh, good. I wasn't even thinking to check that. Minus cosine. One. Wait, so that's -1 minus. I get confused with. Okay.
Just 2, I think, isn't it? -1. 1 minus -1. Is that what it is?
I think so, yeah.
I think it's 2.
Okay, so we're getting 4 pi r squared. And that's to be expected, I think. Just a normal surface area. Because that integral is just, it evaluates to 2 pi times 2.
Okay.
Because the only thing that's not regular spherical stuff is whatever's happening with dt and dr, but we held those constant, so.
Yeah, okay, okay.
I guess, so here the 3 volume is going to be different.
Funky, yeah.
And so for volume, it's still a square root, all the relevant parts of G times each other. So the radius will be 1 minus AR squared, or the radius piece. We get an R squared square root, so just R, and then an R squared sine squared, square rooted.
Cool.
dr d theta d phi. R goes from 0 to big R. D theta 0 to pi. D phi 0 to 2 pi. Okay. So we have R squared sine squared, or sine times 1, so that's a third R cubed sine theta.
You know, what you could do is like all this is the same thing we just did, isn't it?
Oh, yeah,
So
these
that
are like
should give us
independent, right? We could make it
yeah. So
two
this
integrals times each other.
should give us four. This should give us 4 pi with these two.
We can even just, yeah, change the order of integration. Okay, I like that. So we should get a 4 pi.
And then we just got to integrate the R part. Does that seem right? I think that's all legit.
Yeah, because we could have changed the order of integration and gotten this, I think.
You know what I usually do when they're kind of split up like that? I just separate them.
Yeah, we could have done that too. I don't think there's an issue with doing that. Fifth. AR to the 5th.
Well, that's weird.
It is.
Should we get a common denominator? I want to know when this is 0.
True, yeah. uh um
I wonder what this capital A is.
I don't know. Is there also a value of A that would make this just regular old spherical? That might be a good thing to check. Would A equal 0? Yeah, A equals 0 should give us regular spherical.
Yeah, nice.
So if A equals 0 here, we get 4/3 pi r cubed.
Yeah.
Huh. Okay.
And for part A, right? Is that how you got it? So for part A, if you can let A equal 0, we get what we would expect as well.
Yeah, I just looked at the line element to figure that out, but yeah. Okay. Part D now is where it's getting weirder. Calculate the 4 volume of a 4-dimensional tube bounded by a sphere of coordinate radius r into t equals constant plane separated by a time capital T.
Okay, what does that mean? A 4-dimensional tube.
Yeah, what is a 4-dimensional tube?
I guess we'd have to do a quadruple integral, would we?
I guess so, yeah. It's a four-dimensional tube made up of three-dimensional spheres, I guess. And so I am seeing for a 4 volume, you put a negative sign in front of all the g's, and then you square root it.
Oh.
They're using small v for 4 volume for some reason.
Oh yeah, I see it on page 147.
Yeah. Man, a quadruple integral. And I guess if we had mixed terms, oh, well, I don't know what happened if we had like a DRDT or something. Oh, so the negative in front, it really just fixes the negative that's in front of the DT part. That's all that happens there. So I'm going to get 1 minus AR squared from the time. And another 1 minus AR squared from the radius. So I'll just square that. And then the rest will be as before. So small r squared sine theta. dt dr d theta d phi. Oh my god. Okay. And then what's the time separated by a time t? So I assume that's from 0 to t.
Yeah, let's try it.
And all the other bounds are going to be the same. So I think we can do the same trick as last time and just take our previous answer and multiply it by something.
We'll have to integrate the r again because it's different this time.
Oh, yeah, you're right. But we can still get rid of the theta and phi.
And the t integral is just capital T, so it's probably 4 pi t times.
Yeah. Okay. Can I mental math this out? We have an r squared minus 2a r to the 4th plus a squared r to the 6th dr.
Mm-hmm.
Okay. 4 pi t. Well, actually, we can just go straight to plugging it in. Third r cubed minus 2/5 a r to the 5th plus 1/7 a squared r to the 7th.
Weird.
Because we get another common denominator here. Oh, well, 3, 5, and 7, it's like 210 or something.
105.
105, okay.
Yeah.
We can factor out an r cubed.
Is this yeah, okay. Oh yeah, factor out an r cubed, yeah.
105 divided by 3. 37?
35.
Oh.
35.
Okay. I'm trusting you.
Yeah, 105 is just 3 times 5 times 7. So it's just like,
okay.
Yeah.
Hey, Alex. And then 21. So 42. And then I feel like I should know this for 7, but I don't. 15?
3 5s, yep, 15.
In general, we need the determinant of the metric and not just the diagonal. Okay, I was wondering how that would change for the mixed ones. Oh, they even say that in the next paragraph, if G is the determinant. Nice. And then if it's diagonal, that does work out to be the determinant with a negative sign.
Oh.
35 minus 42 AR squared, 15 A squared R to the fourth. Wow. Does that polynomial factor? Probably not worth doing. I don't think that'll give us any insight. And so if A equals 0 here, then we get 4/3 pi r cubed times time. So if we happen to be on the t equals 1 slice of time, that would work out as the normal volume.
Yeah, okay.
Oh wait, they say 2t equals constant planes. Maybe should we have done like t0 and t1?
I mean, but they were separated by capital T, so I don't think it matters which.
Right, yeah, because we would just get a subtraction that's equal to capital T anyway. Okay. Yeah. Nice. Well, that one's feel like, I mean, I guess we can check the answer to be sure, but I feel like we did that one right. 14. Why would you show it in such a weird way? R times 1 minus a third Kasai squared, where Kasai is R root A. We get the same thing, okay. I think. I don't know why they did that, but maybe it shows up later on in the question too. Yeah, they repeat the same Kasai.
Okay, there's probably a reason, right?
Probably. Maybe by the time we get to part D, it'll be more clear why we don't want it.
What'd they get for B?
For B, 4 pi r squared.
So we get that right.
Yeah. R squared A, 1 minus 3/5. I think we get the same. It just looks a little bit different.
So they're kind of writing it as the regular area or the regular volume we would expect times like one plus a delta, some kind of delta or something.
Oh yeah, looks like it.
Okay.
Okay, I don't feel like checking all the fractions, but this is the same form as the answer that we got, so for part D.
Yeah, I trust it. It looks like it's probably good.
Yeah. Noish. Number 15 is the next one I pulled. Oh hey, this is the peanut one. Hey, Dr. Haffis. Honestly, this is a simpler version of the one we just did, I think. So yeah, the area. Okay. That's not what I want to write. We have an a squared square rooted, so a times a squared f squared square rooted. So a sine theta 1 minus 3/4 sine squared theta. I guess phi is easier to integrate in first. Then we solve it. So the phi gives us a 2 pi. A squared can come out front. Sine cubed. Oh, actually, that's not a bad one. Because it's sine theta times 1 minus cosine squared.
Cool.
I was this close to opening up Wolfram.
No, come on, no Wolfram. We got it.
Yeah, if it was a harder one like sine to the fourth, I would have. But sine cubed is simple enough. Negative cosine
What are you gonna
theta.
do when you're on the desert island with no Wolfram?
Probably try to survive and break open coconuts or whatever.
Yeah.
Definitely not doing relativity.
Yeah. Yeah.
I could be
Good
like
answer.
Archimedes and drawing into the sand, I guess. Um. Okay, so I'm gonna do too much in my head here, but that negative can cancel with that negative, so plus 3/4. That one integrates to u, which is cosine theta, minus 3/4 times a third cosine cubed theta. I gotta fact check this. I think it's good. Negative cosine theta from 0 to pi. I think we said that's 2. Plus 3/2.
Yeah. Yeah, it's 2.
Okay. A fourth times.
It should be 2 as well, I think.
It's cubed. Oh, but we cube it before we subtract or we add them. So yeah. Okay. So that's a half.
Nice.
Is that 6 pi a squared?
Yeah.
Okay. That seems reasonable-ish.
So what is it for a sphere? It's like 4 pi r squared.
Yeah.
And this peanut was like a stretched out sphere. A little bit.
Oh yeah. I was thinking of it as like a squishing a sphere, but yeah, you could stretch it.
Yeah, I think it's more like we stretched it. I'm looking at the picture in the book on page 27. It's kind of like they took a sphere and they stretched it north-south a little bit. I think that's what they did.
Yeah, okay. So like I imagine like taking a balloon and like squeezing it in the middle. That would make it expand a bit.
Yeah.
Checking the answer. Oh no. 2 pi a squared.
What?
All that convincing for nothing.
Oh, maybe there's a sign wrong with this trig. You sure
Probably.
they said 2? Is that the end of the question? The end of the solution? 2 pi a squared?
Looks like it.
Oh, okay. So we got a factor of 3 we don't need here. Are these signs backwards here, maybe?
Oh wait, I said this is 2. There's no negative sign in front of it though. Yeah. If that was a negative, it would be getting 0. So I probably made another sign mistake. Ugh, this is what I get for doing too much in my head. TSXer probability theory. I might be able to do it. It's been a long time since I've done probability theory. Need someone in chat will be able to do it, but I'm not doing math help right this instant. If you can hold on for like 45 minutes, I can take a look at it. If you want to post your question in Discord, just put it out there in chat. If someone wants to help with it, they can. I won't be able to take a look at it until after I'm done with this reading group, though. The last sign is wrong. It.
Oh, -1, Yeah, it should be -2 here.
I
Oh
canceled
boy.
the negative out front. I guess I'm just doing too much mental math.
Okay, so that's yeah. So this is all 1 now.
Okay. There we go.
So what does that mean? Maybe I don't understand this picture of this peanut here.
Yeah, I thought it would make sense if it was bigger than a sphere. What is A? Well, I mean, maybe A isn't like what is it? A isn't the radius necessarily. Like, what is the radius of a peanut?
Yeah, I remember way back in the first week. I think it was FizzBuzz did a graph of this because I was a little confused by it. What did they say here? The equator. Oh, the maximum circumference is 8 pi over 9a. Oh, 8/9 pi a. Yeah, it says there the maximum circumference is 8/9 pi times a. So that's less than pi a. So the a must be, yeah, the a is not the radius from the axis there. I don't think.
Yeah. Like A is just it doesn't have a direct physical interpretation like the radius of a sphere. I don't think it does affect the shape, but not as easily understood as the radius of a sphere. Oh God, TSXer, I'm not confident I can do that one.
Oh, look what it says there in equation 223. It says the distance from pole to pole is pi times a. So that means
Right.
all the way from top to bottom is pi times a.
So funny enough, if you went all the way, like pole to pole is just going up one side of the peanut. If you went up and then back down, that'd be the circumference of the sphere, like 2 pi a.
Yeah.
Yeah, TSXer, I would just have to Google that one. I probably wouldn't be able to solve it. Someone in chat might see it and get interested, but my probability isn't that strong. Hey, advanced physics or Akshat, maybe. Okay. Yeah, maybe it's just dangerous to think of A as the same thing. A isn't quite a radius, so maybe we shouldn't necessarily treat it like that.
Right. I think that's where I got tripped up way back when we first did this chapter. Because I remember I tried graphing it on Desmos and like spinning it around, and it was pointy at the top and the bottom, and I was doing something wrong.
Right.
Remember that? Yeah.
Yeah, Dr. Cook and Fizzbuzz figured out the real shape of it. I don't remember. I don't know how
Yeah.
they did it though. They probably, I don't know.
I don't remember either. I'd have to look at it again.
Yeah, same.
But we had the right idea. We just screwed up the dumb calculus.
Mm-hmm.
But we had the right idea.
This is the last question that I pulled, number 17.
Okay.
We could always get another one if we wanted, I guess, but let's see. It's another S1, which let's see. Calculate the three-dimensional volume on T equals constant slice of the wormhole geometry, bounded by two spheres of coordinate radius r on each side of the throat.
Well, we just did something like this. I feel like we might be able to do that.
Yeah.
How come that last sentence doesn't finish?
Oh, because that comes from the example problem where the wormhole is from. I guess I included that
Oh, I see.
sentence
I see.
just to
Okay, I'm
explain
with
what
you.
B is.
I'm with you. I thought that was part of the question, but that's
No.
something else. Yeah. Okay.
Equals constant slice of the wormhole geometry. Bounded by two spheres.
So wouldn't we just do the same exact thing you just did, like a triple integral of r phi theta?
Well, I'm trying to figure out what they mean by bounded by two spheres. Like, I'm imagining a tube that is the throat of the wormhole with a sphere down here and a sphere up here, and we want the volume of that in between them. It's like a Calc 3 problem where you have to find the volume between two surfaces. I think that's what they mean.
Yeah. Yeah, but I think the same formula from
Oh yeah, the same
7.6 just kind
formula.
of gives the answer.
For sure. Well,
The
I'm
question
afraid
is,
that
what are
the
the
bounds,
bounds?
yeah, might need to be parameterized.
Yeah. Bounded by two spheres of coordinate radius r. Wouldn't it just be 0 to capital R then? I think so. And then the phi goes from 0 to 2 pi, and the theta goes from 0 to pi? Or wait. Is it like pi to negative pi? It might be.
I need to look at this again.
Yeah, it's on page 151.
What did they calculate as part of these? God, this example problem takes up like 3 pages.
Yeah.
Like, I'm a little bit worried that these bounds aren't going to be simple. Like, what did they
Well,
get the
let's see.
radius of the throat is? Assuming they did calculate that.
They said it was 2 pi b in the caption underneath the figure.
Oh, the circumference has... Okay, so the radius of it is b. I guess, yeah, we're sitting a sphere on top of one or like at either end of the wormhole. And we want between the two spheres. So do we need to fix an origin somewhere? We could also do it, just worry about one sphere and get to the halfway point and multiply by 2.
Yeah, okay. That should work.
I don't know if we want to take the origin as the middle of the sphere or as the middle of the throat. Maybe the middle of the sphere.
We're trying to find a 3D volume with t equals constant. So bounded by two spheres of coordinate radius r on each side of the throat. Don't you think when I was reading this, and I haven't read it since last week,
Mm-hmm.
but when I was reading it, I was imagining this picture here as made up of like cross-sectional circles, right? Like there's cross-sectional circles to this picture. And every
Okay.
one of those cross-sectional circles, like if I cut it with a horizontal slice, I get a circle, right? But that circle really, it represents a sphere, right? So it's kind of like that picture. You remember that picture we had last week from complex analysis or whatever, and it was something like this, and you had like a ball and a ball and a ball and balls coming up like this.
Oh, yeah.
I'm thinking this picture is the same. It's like every one of those is a sphere, but we're just taking like a cross section of each sphere to make that picture there, I think.
Huh.
That's the way I'm imagining it. So I think when they say two spheres of coordinate radius r, I think you just have to go like this, like that top plane there. Oh, there we go again. That top plane there, I think is r,
That would
and the
make life
bottom one would
easier.
also be r, wouldn't it? So you're saying we could go from 0 to r and just double it?
Um,
Yeah, I want to do this. 0 to r, 0 to... I forget which one's which. I can't tell which one's which. One of these is... Oh, no, one of these should be minus pi to pi or... Oops.
phi ranges 0 to 2 pi, theta ranges 0 to pi. I mean, I don't know if they need to range like that for this integral. I assume they do, but that's like their maximum range. We probably will have to double it Hamiltonian dynamics, yeah. I'm still trying to understand what these bounds actually, because we're choosing an origin when we choose bounds, and so I'm trying to figure out what our origin is.
The other thing is, I think when theta is 0, you're in the throat of this wormhole, aren't you? And if theta is pi, you're... Yeah, I don't know.
Maybe theta does take care of that. If we go from 0 to pi.
Or should it be from minus pi to pi? No, minus
No.
pi over 2 to pi over 2.
Uh,
No, 0 to pi. They measure it from from North Pole to...
yeah.
Okay.
0
0 to pi is probably good.
That's what we were doing before, at least.
Yeah.
Okay, so yeah, I think we don't need to multiply by 2 then. 0 to r. We're choosing the origin as like the halfway point through the throat. 0 to pi. 0 to 2 pi. It is a straightforward one, allegedly, so...
Yeah, let's just do it.
Okay.
Just cross our fingers and see what we get.
Yeah. We were saying sine theta d phi d phi. Is that 4 pi or 2 pi? I think it's 4 pi. Because the sine contributes
yeah.
a 2.
Yeah.
Yeah,
4
so
pi.
4 pi. Alright, just go straight to big R. Okay, so if b equals 0, we get a sphere. We get a common denominator again. I don't know if it's really that important, though.
What'd you say?
We could get another common denominator. I don't think it's really important, though.
No, probably not.
I guess.
What did they say? Did they say what B stood for? You were saying B was like the.
It's just some constant. That's why I included it in the screenshot. That's all we know about B. It's just some constant.
Yeah.
It should control the dimensions of the wormhole, or like I guess it controls the thickness or how wide the throat is, because the throat has circumference 2 pi b.
Yeah. All right. You want to check it? You feel confident? I mean, it might be right.
I don't feel as confident this one as I have in others, but let's just check it. We're off by a factor of 2. They go from minus r to plus r.
Oh shit! Really?
Why? No, Hamiltonian, I agreed with you.
Well, I was saying I thought it was R at the top and R at the bottom, but I guess yeah, I was thinking it was R up here and it was. I was thinking these were both R.
I guess somehow we only captured one of the spheres by doing 0 to r. I have a hard time understanding that, though. Yeah, I don't know. It's really weird because I was just thinking about it in like spherical coordinates again, and you never have negative r, or at least you don't usually have negative r in spherical. But I
Yeah.
guess this is another situation where we shouldn't lean too heavily on spherical coordinates. I don't know.
Yeah, because normally if you want the volume, you don't go from minus R to R because I mean, when you spin it around, that takes care of the other side.
Yeah, you'd be like getting the same sphere twice.
Yeah.
That's weird. Um,
Hmm. So we only did. So what does that mean? We did like the top half of that wormhole picture, and we didn't do the
apparently.
bottom half.
Yeah.
Hmm. Okay.
Oh, I'm sorry, Vid.
Well, we did skip one, but I had no idea how to do it.
I don't want to go back to that one. There's plenty of other interesting looking ones. Like I could just pull another one since we got another like 15 or 20 minutes. Uh, I'm looking at 21. It's catching my eye because there's a graph with it. I don't know if it's gonna be. um, I don't know what it's gonna be like though.
Yeah, we could try it.
All right. Okay. Two-dimensional flat space with a skew coordinate system. X1, X2 axes making an angle of 45 degrees with each other. Reproduce the accompanying coordinate grid and draw on the basis vectors E1, E2 of a coordinate basis associated with X1, X2. And so this is, I think, the thing that's kind of like Graham Schmidt. I mean, is it cheating to just say E1, E2?
Oh, I was gonna say, I wanted to say like E1 here and E2 here.
Oh, I was saying I thought E implied. Oh no, it's the hats that imply orthonormal. Or for some reason, I thought the E ones need to be orthogonal. I guess I might be making stuff up.
I might be misunderstanding the question. Oh, they did say this is a 2D flat space with a skew coordinate system, and the axes are 45 degrees to each other.
Right. Okay, I think E is just any basis. So I think we just match. It's not pure orthogonal. Okay. So would E1 be 1, 0 and E2 1, 1?
0, 1, wouldn't it?
Well, we need the 45-degree angle, right?
Yeah. Basis vectors of a coordinate basis associated with x1, x2. So x1 is this axis. x2 is this axis.
Hamiltonian dynamics agrees for what it's worth. It is kind of weird. Like, I feel like it should be 0, 1 in some sense, but I think they want 1, 1.
Oh. Oh, wait a second. So if I draw this line, is this set up so that these points are exactly above each other? Is that what they did?
I assume a
Let me
45-degree angle would have to make something like that. I'm having a hard time imagining, or I'm having a hard time being certain.
Yeah, that line I just put there looks like it's.
It looks
Doesn't that
straight,
line look
yeah.
like 90 right here? Oh, so they did that on purpose, did they? Because I didn't know where you were getting the 1, 1 from, but you're saying
Well, I just chose x1 to be 1, 0, and then the 1, 1 is whatever makes a 45-degree angle. So that's like an isosceles right triangle. If that's 1, that has to be 1. So the point up here is 1, 1.
Yeah, but wouldn't that have depended on like how they chose to lay these lines out? Like, I mean, they could have made the x2, like depending on what one unit is in x2 versus one unit in x1. Like, I think they did that on purpose so that it would come out to be exactly like a, right? Because if I'd kept, so in other words, let's see, what am I trying to say? So right here, if this distance here is 1, then this distance here, I want to say on the page is radical 2, right?
Yeah.
But anyway, okay. So I agree. I think I understand what you guys are talking about now.
Okay. So I don't think I completely understand, to be honest. I'm just kind of going with it.
I guess I'm still not sure why that would be a coordinate basis associated with x2, because doesn't my E2 vector, this is going back to linear algebra again, right? When you're talking about like vectors vectors representing a point in space, and you have to say, oh, but wait a second. Now, what basis are we using? What basis do these things measure in? You can rescale. It could be 2, 2. Okay.
I guess the coordinate basis, I'm just thinking of it right now as another word for R2. And that E1 and E2 are a set of vectors that span R2, I guess. Would have the property of making an angle of 45 degrees. Hey, programmer Ianot. Jasu, hey, it's been a minute. How have you been? Good to see you. Okay, so what's up with part B? Calculate the components of the metric GAB from the scalar product of the basis vectors.
We still didn't do part A, though.
Wait, I thought this was the answer. Oh, we have to draw them.
Yeah. Let it move.
Programming paper opening submit this week? Nice, that's huge. Good luck on completing it. Oh, is that... Oh, that's the arrow tool you're using?
Yeah.
Nice. I'd never used the shapes. Maybe they'd help, though.
So this is E1.
Right.
I gotta get better. How'd you get so good at this white space? What's this thing we're using called again? Whiteboard?
Excalibur?
Excalibur. How'd you get good at this?
I don't know. I really I get the buttons of my tablet mixed up a lot, but I think I just kind of draw. I do have to always look at the top to make sure I have the right tools selected. But other than that, I'm just kind of drawing. I don't know.
How I mute this Discord thing here?
Are you getting sounds?
Yeah, right click it, right? Okay, it's fine. It's fine.
Okay. Solo authoring, so I've had to
So
jump through
then
some
part
hoops.
B.
They'll cover the... I'm not sure what those acronyms are, but I'm sure it's not easy to deal with that stuff. Calculate the components of the metric GAB from the scalar product of the basis vectors. Hey Krishna. What's the relation between GAB and the scalar product? Oh. No, it's for orthonormal. The to have your work be open access. Oh, you have to pay fees for that? That's annoying. Okay, yeah, here's the same formula that Hamilton and Adams just said, I think. Or it will get us to the same place. Harris, I'm just a tutor. American Chemical Society. Oh, okay. Okay, so yeah, I think this is the thing that we want for part B. Because we know that A dot B... Well, how do we know what the dot product is if we don't know what G is yet?
Couldn't we just do 1 times 1 plus 0 times 1?
That's what I want to do. I feel like that's kind of... I don't know. It feels like cheating to me for whatever reason. Total C is the standard... Oh, it did? Oh, flat space. Okay. Yep. Okay, I agree. So they dot to 1. And so if we want to find, say, G11, then that'll be times 1 times 1. So G11 is 1. Wait, if it's just flat space, isn't it diagonal? Like, it's just the identity matrix, isn't it? We shouldn't need to use this formula if we know it's flat space. And they do say it's flat space. Do we get anything weird for... I guess G22 is different. Because times 1 times 0, right? So we actually... Okay, we're getting... one and then all zeros. Is that right? Oh, no, not necessarily. Yeah, G12 is different. Because that's times 1 times 1. Okay, now where does G12 go in the matrix? Up here?
Top right, I guess.
Yeah, I guess. Nice programmer. Okay. I guess that's the answer for part B.
Wait a second. What
Oh.
about your third equation here?
Oh, I didn't bother. Well. Oh. I just took that to mean G22 is 0. That doesn't really... That does seem like an issue though, right? Oh. Okay, G22 is equal to... Oh. G22 is equal to E2 dot E2. They dot to 2. That doesn't... And then, oh, the component will be 1. Oh my god. Okay, so I really messed that one up. Okay, yeah, I forgot the dot product will be different for each one. So the first one, I should actually write this out because I'm gonna E1 dot E1 is where the one came from for that one. And that's still one, so that is okay. This one is E2 dot E2, which is 2. And then G12, that still dots to 1. My right-hand sides are wrong. It's this one is the first component of E1, which is 1. And this one is the first component of E1, which is 1. The first component of E2. Why did I make, I put that as a 2 for some reason? Oh, they're repeated indices. Oh my god.
What?
Repeated indices imply summation, I think. I hate this notation.
I've lost a thread again. I don't know what's going on.
There is a double sum in this expression. One sum over A, the other over B. So we're going to get like a system of equations. Freaking, I hate subscripts and superscripts and everything that they stand for.
Shouldn't this just be easy? I don't know why this is not just easy.
It needs to take general relativity and just make it easier. I don't care if it's right or wrong. Just make it easier.
I think it is easy. It just hasn't been explained, at least to me, in an easy way. I know there's an easy way to do this.
Maybe, yeah. I mean, sometime in the future, I'd definitely be open to
I mean, isn't this just a linear algebra question? Aren't we just doing a change of bases or something here? Or is it not that easy?
I don't know. I really don't know. Wait, no, I don't. This isn't going to be the same. Okay, Hamilton names, and what you're saying, what is the G of E1, E2? Or E1, E1? Like, I don't get what the middle part of those equalities are. In this case, it's E1 dot E2. So this is G. So wait, is G a function here, or is it just some scalar? Like, is this G of? Or is it G times? G is a tensor. I don't know what tensors are yet. We haven't gotten that far.
I really picked this wrong year to stop drinking.
We have not seen a tensor yet in this book. Is there a worse way that we can do this by that avoids tensors? Like it can we just do some stupid double something?
Oh, tensors come up in chapter 20.
You think so? Okay. Yeah, I remember that being like a feature of this book that they avoid tensors as long as they can.
I think he said that at the start. He said he does relativity in a really different order to other teachers or other books.
Oh, I messed that up. So G11. Yeah, I'm not entirely sold on this textbook. Um, it's not bad, but I don't know if it's my favorite.
Well, it's my favorite GR book I ever read.
Yeah, I guess it's the only one for me.
Yeah.
G21. So the second component of E1, which is 0, plus G uh times 0 times 1 plus G22 times 0 times 0. I hope that's right. So I'm still getting at least for the first component that G11 is 1. But I assume we're going to get something different when it comes time to involve E2. Okay, so E1 dot E2 is 1. G11 times uh 1 times 1. Is there I hope I'm applying the double sum right. I'm just kind of going straight to the end. I should justify this to myself a bit more. One B E1 1 E2 B. You're saying I'm applying the double sum right? I was just concerned that there's some weird like multiplication thing that actually I guess not. I think I can see it now. Usually when I see a double sum when I'm doing a problem, I think I've done something wrong. G12 So times 1, but then the second component of E2 is now 1. So we're going to get a system of equations. Oh, G11 we already know, so it won't be the end of the world. Times 0 times 1.
Okay, this is definitely not. This is not as easy as I thought it was.
Same.
I didn't realize this was like a 4x4 system we were working on.
Yeah, I mean it's gonna be a simple one as far as those systems go, but yeah. And I think there is some kind of linear algebra way that we could probably automate this if we knew it better, but
yeah.
Okay, so if G11 is 1, we get 1 plus G12. So G12 is 0. Ugh. Okay. Now we need to do E2.E2. That's the only other dot product we can do. I assume it's going to be like symmetric. Change of basis thingy.
It's supposed to be symmetric. I think they said the G matrix is supposed to be symmetric.
I think it doesn't have to be symmetric. I don't know though. He famished. Popping over to the YouTube side. Does G have to... I mean, I can definitely believe it in this case that it's symmetric. Does it always have to be? E2.E2 is 2. It does? Okay. Times 1 times 1. Oh, so these are all just going to be 1s because E2 is 1, 1. So G12 plus G21 plus G22. YouTube is better. The video maybe. I don't know about the chat. The chat is better with you in it though. 2 is equal to 1 plus 0 plus 0 plus... Oh, wait. I'm just getting the identity matrix.
Oh.
It's the definition of a metric? Okay. Is this supposed to be... I thought we said it wasn't going to be identity. I think I just want to check the answer for part B because I don't know if this is how we're supposed to do it. I assume it is, but this is number 21.
Whoa.
They don't actually say for part A what E1 and E2 are, but I think we... Oh. That's kind of funny. I think we have the right idea. They also drew some orthogonal axes for some reason, but...
X prime 1 and X prime 2. Okay.
Yeah. Wait, G... Oh my god, dude, we did it wrong.
There's root 2's in it? How'd they get it?
GAB equals EA dot EB. It was the thing I was doing. Well, no, not exactly. We just used the wrong formula, apparently. I feel like this should also work, though. Oh, I guess this is the formula right above the one that I actually screenshotted. Ugh. And that has no double sum. Ugh, okay. So we just take every possible dot product, and those are the actual... Okay. I'm going to delete the stuff that I wrote here. Because I guess I see what they're doing now. I should have screenshotted the formula right above that one. And said that G11 is equal to E1 dot E1, which is 1. G21 equals G12 equals E1 dot E1 dot E2, which is still 1. G22 is E2 dot E2, which is 2. Why do they get square roots and negatives? Are they getting 1 over root 2 on the diagonal?
Maybe this E2 is wrong.
The choice of E2 was different. Are we right for the things that we chose then?
Oh, you were saying you got to normalize it? Maybe that's the problem. This thing's not length 1.
I thought I didn't have to be.
Yeah, because there's no hat on it, right?
Well, the hat is also orthogonal. I don't know if we're also right or if we're wrong. It's like I was saying we're also right. Maybe we can update it just so it matches what the book is doing. But it didn't seem like we had to normalize them. We're also right. Okay.
Oh, now it works, right?
You're just getting 1.
Yeah, now it works.
GR, we can use whatever coordinates we like. And apparently no coordinates if you study that. Which I don't understand how you even
This whole
begin to anything. Sorry, what?
No, I was just going to say this whole course is pretend.
Yeah. It's like, whose line is it? Anyway, we're just making up as we go. Coordinates are a social construct. They kind of are. Or it's a scientific construct, I guess. On the coordinate grid, draw a vector v of length 2, making an angle of 30 degrees with the x-axis. What x-axis? There's two x-axes. We have an x1 and an x2. Be more specific, please.
Okay, wait a sec. I'm gonna go to the book mistakes.
Oh, true. Akshat, for JDA Advanced, the answer is yes, but I don't like them. I'd never heard of any of those other ones.
Yeah. Problem 21, part C. Replace x-axis with x1 axis.
Oh, okay.
There you go.
That's what I assumed they would have meant, but
Yeah.
it's like I'm getting a little bit over it right now with all these x's and vectors and stuff.
Yeah.
Draw vector.
I'm a little discouraged. Hopefully next chapter is a little better. That's what I remember saying that in chapter 5 too.
So I've nearly read chapter 8, and it's a lot. It's shorter, and there's some parts that I don't quite grasp, but I feel way better about it than chapter 7. This is easily the worst chapter for me.
Yeah, I was reading another book that was talking about geodesics, that visual differential geometry book.
Oh, nice. Draw a vector v of length 2, making an angle of 30 degrees with the x1 axis. Calculate the components VA for this vector. Can you give a geometric constructing for finding VA? Okay.
So now my vector E2 is wrong.
Well,
because it's too long now.
We don't know what the scaling is. We don't know these are ones, I guess. Like each of the vertical lines or horizontal lines, or both, really. We can say that the scaling is like one's along there and 1 over root 2 along there, I assume.
Well, if you got a circle and you go like this, let's see. If that's a unit circle, then I know you can find like a, right. So if you go to 1/2 here, if that's 1, and you come over, that's your 30, right?
I don't know how you got that. What? Or just from the unit circle?
Yeah, from the unit circle. Like
Okay.
if you want to get a guesstimation of what a 30-degree angle is, if you can, I'll tell you what, we'll make it better. How do I erase this without erasing the whole picture again? Okay. Here we go. Aha. Get a nice unit circle here.
That is crazy how upshot. Yeah, this is funny. We have to get the components in with respect to the E1, E2 basis vectors, I think.
There we go. So if this was 1 and this was 1, right? So let's see. No. What the heck?
Two sine 30, two. Oh yeah, we could definitely write in the standard basis pretty easily. That's probably the best thing to start with. Maybe I shouldn't. I was going to do something weird with the dot product and multiplying things out. I'm working on the algebraic way. If you want, you can keep on going with good geometry. We do have
I'm
to
just
do both,
drawing a
I think.
picture.
Yeah.
I'm just having fun. What if I wanted to make this length 2?
Um,
Oh yeah, there you go.
but then we need to take root 3, 1 as a linear combination of the basis we want it in. Then AB will be our answer. There's a matrix way of doing this that I already can't remember, but it doesn't matter because this is really a simple system anyway. So I think wait, oh no, I got it wrong. That wasn't our other basis vector. This is our other basis vector. Which complicates it slightly. So B is root 2. Oh, A is still root 3 minus 1. It's kind of funny. I think that makes sense.
I do see how to do this, I think. Wait a second. No.
Yeah, so they do want the geometric construction too, so this is good. I was
Did you get the numbers?
yeah,
root 3 minus 1 and root 2?
yeah.
Yeah, because root 2 times 1 over root 2 is 1, right? That's making sense. So the point I'm trying to find is this point right here on my picture, if you're looking at my picture.
Yep, I'm looking.
And so that distance there is definitely 1. And
So maybe it's easiest to get the height right by traveling along the diagonal basis first, and then correct with the horizontal one. like thinking about it geometrically. I think it's kind of how the
Root 3
algebra
minus 1.
followed too.
So let's just so wait a second now. Let's look at this picture. So let's say I drew this. Let's say I drew this triangle here, right?
Mm-hmm.
This triangle. So let me draw it just down here. So this distance is 1. This is 30. So this should be 2, and this should be root 3, right? So
Yeah, 30.
now,
Yeah.
if we multiply your E2 vector by root 2, E2 times root 2 gives us 1, 1. And yeah, it's coming out perfectly. And then E1 so if we want to go root 3 in this direction, we have to go, we're already going 1 in that direction from going up the diagonal one, right?
Mm-hmm.
And then we have to do another root 3 minus 1 in that direction. It seems like it makes sense.
Okay.
Sorry, I'm just getting caught up to what you got. So that would give us root 3 minus 1 comma 0. And if we add these together, we get the sum is root 3
Oh,
1,
nice.
which is what we're looking for.
Yeah.
Still, I don't know if that's cool that it makes sense, but how do we do it? If we just did a geometric construction, how would we do it? So if all we had, looking at this picture, if all we had was these two red vectors, how would we find this point here?
Well, that's what I
I'm kind of
was
thinking.
saying before. Like, you just like correct the height using the, or get the right height using the diagonal vector, just so you have like that dimension, okay, and then correct the horizontal afterward.
So we're kind of assuming that we have these numbers radical 2 and radical 3 minus 1, and that we can measure them somehow.
Oh, that's what you mean. I guess so.
Yeah, I'm trying to imagine I didn't have a measuring tool. But maybe, I don't know. Maybe we can't do it without
I assume we would need one.
All right. Well, I guess we're done then.
Okay. Let's see what the answer is.
Or what you could do is, yeah, well.
What the hell are they doing? Derivatives are involved? And their geometric explanation is just that the values follow from a little geometry.
Hey, look, they got the numbers you got. Root 3 minus 1 and root 2. Beautiful.
Oh, okay, I can see it now. Yeah. The derivatives are the change of basis. I have no clue how that works. Okay. I don't know, this kind of felt like a linear algebra question.
Yeah, this part of it sure did. Part B, I didn't understand what we were doing. Part B, I got confused.
Yeah, I just chose the wrong formula, I guess. Or maybe the formula I chose could have worked if I used it better or something, I don't know. Oh well. Oh my god, this took way more time than I thought it would. Okay.
Well, that's all right. That one was kind of cool.
Yeah, just another one where gotta learn what formulas to use.
I don't know. I feel like we were shooting about 50% today.
Yeah, like we did pretty well on like calculating the areas and volumes. I feel like we have that pretty well. Like we got a little bit wrong, but not that much.
I'm glad Hamiltonian dynamics. I'm glad you were here to keep us on track. Thank you for that.
Yeah, thank you. um, so yeah, chapter 8 in terms of pages is relatively shorter. There is one piece of the math that I just can't quite figure out from relatively early on, but it's a small thing. Oh, overall, it's not too bad to understand, at least for me. Okay. Apparently, there's a German mathematician named Wilhelm Killing who has a vector named after him, the Killing vector, which is kind of funny, but those I didn't quite understand either. But overall, I feel like I understand more of chapter 8 than chapter 7 so far.
Okay, well, I'm gonna hope for the best.
Yeah. All right.
And we'll see how it goes.
Yep. Hopefully next week, uh, we'll go well. All right.
Oh, I posted some a couple of complex analysis problems
Oh, that's right.
in the other Discord.
Yeah, I can take a look at them. Like, I guess right now because there's not a question that's waiting. So
I posted the answers too. I probably should have put a spoiler on it.
that's fine. I just won't look too closely.
Yeah, I think I know how to spoiler photos, but I don't remember right now.
Like once you paste it into the chat, there's a little like icon that you can spoiler it with. It's not a big deal though.
All right, maybe I'll go and try and do that now.
I don't know if you can do it afterward, but I don't know. It's
Oh.
up to you. It's fine either way.
Okay.
Okay. Well, thanks for being here. I'll talk to you next time.
Sure. All right. Yep. See ya.
Bye. Okay. Were you to summation of the convention by the end of this? I would love to be converted. I want to love it. It's just it's so hard to love. Oh my god. Okay. Just switching over Twitch and YouTube information. Dr. L. Contravariant to convenient. Contravariant? I never heard of that. That sounds like one of those weird logic terms that I can never keep straight. Like converse, inverse, contrapositive. The least bad option. Yeah, I assume they didn't invent that notation just to torture me. I have to hope that at least. I assume it has to be helpful at some point. I just haven't seen it yet. Contravariant and covariant. Oh, I've heard of those. I haven't learned them though. Uh, I don't know. I, 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 I was trying to think of a joke about like who even cares about coordinate bases and whatever the other. I can't even remember what the other word was. So whatever I get confused them with. Who cares? to chapter 8. Not 8 factorial. There we go. Yeah, the subscripts and the superscripts basically are the summation notation. Yeah. I mean, they mean more than that. Like, you can use them to, like, describe a matrix also, or a vector. But if you have repeated indices, that means summation. And if you have multiple repeated indices, that means multiple summations. And randomly, if you have a superscript in the denominator, it's actually a subscript for reasons that are beyond human comprehension. It's a whole set of notes that does GR without coordinates. It's so inconvenient. I can't imagine what coordinate-free anything looks like. These Christoffel symbols they're introduced just in chapter 8, and when I first got to them, I had to spend so long figuring out what the hell these three things mean. I'm still not complete. Actually, you know what? Gamma mentioned. It's not the gamma that you would probably know, Papadoria. This is an evil, evil gamma that is made to destroy minds in spirits. Rather than being related to the gamma function, this gamma is the Christoffel symbols, because it's a vector, I guess. I think it's just a vector, but it's a weird vector. Get me away from the evil gamma. Yeah. It's not a vector. Well, I thought that's what the superscript was. Dude, I don't fucking know. We're summing over beta and gamma. I don't know. I feel like I understood it after Googling about it enough and looking at it for long enough, and now I don't remember what conclusion I came to. Yeah, I don't know. Like, I really wish they would just write out once what this actually looks like without the subscripts and superscripts, but they just never do. Or that they only did it for the basic cases for just like a single superscript or a single subscript, and they never actually explicitly say what it means in the book. And I just that's the main reason I'm having a really hard time with it. They expect you to figure it out. But let's maybe switch gears to the complex analysis that Finbox posted. Some complex integrals. I don't Einstein, it might be related to Einstein notation. I don't know what it actually is. I think it's actually introduced way later. The book doesn't call it a particular type of notation. But like and rather than writing out this expression, you can say this and the meaning is supposed to be understood. And so like this I get, it's not that hard, but when the double sums start happening, or the double sum with the superscript, I don't know what the fuck any of it means. So that is the Einstein summation convention. Okay. The book hasn't called it by that name yet. I don't remember them doing that. Griffith's electrodynamics book the other day, he was driving me crazy too. Wait, does he use the same notation or driving crazy for a different reason? A different reason? Okay. So on Thursday, I was complaining about the problems from the complex analysis book that we've been using for the reading group because they're either trivial or ridiculously difficult with no clear path forward that I've been able to find. So then Vox posted a bunch of integrals at a different book has. So I thought it might be fun to try these. Had to do with the del operator. Okay. Physics books often do explanation by vibes. It doesn't go well with me. Matthew, there's only 4 quadrants available for sub and superscript, not nearly enough for you math people. Yeah. Ugh. Oh my god, dude. I can definitely see the book eventually, like, okay, here, what, this isn't enough room in that margin. Let's just take an uppercase gamma. I hope eventually we're gonna get to alpha, beta, lowercase gamma, fish, a bowl of soup, regular A and B, and then Roman numeral 4. I hope this will mean something eventually. Hey, Sage. And I hope eventually that we start writing these indices in curved space-time too, in 4 dimensions. So they start like, and then when you project it onto this Euclidean page, they start like overlapping each other. Like, here's stick figure. It really means the world to you. Yeah. Doing good, Sage. How are you doing? 2+1 get nice, couldn't understand algebra until you use random shapes as variables. That's kind of funny. I like that. That's a very enormous opposite for. I just like to make fun of it. Because I like to make fun of things that I don't understand. Fish bowl of soup, yeah. The random shapes as variables, I like that. It's a very like Zach thing to do. So we make fun of you, yeah, Slim. I just don't get you. I stay up at night just like being like, what is up with that Slim dude? Yeah, I'd love to go and read Griffiths. I seldom finish Purcell though. Let's look at we only have the answers to the odd numbers, so let's go for number 17 first. Clockwise around the unit circle. Now, if it's clockwise around the unit circle, I'm just going to guess the answer is -2 pi I. I should justify that, though. right? So maybe the easiest thing to justify it is to split it into two. This integral is 0. This integral... Can I just say that's clearly minus 2 pi I? We could justify it with Cauchy's integral formula, I think. B dot del A. Oh, what? Wait. B dot del, like that A? Why would the parentheses, that parentheses right there makes that so weird? What page is that on? Oh, we're gonna have different editions. Page 21. Oh yeah. Or wait. Where are we? Oh, like right there. Yeah. What's going on there? What? I guess A dot del is still going to be like the divergence, I guess, of A. Like you calculate the divergence of A and then that's a scalar. So the divergence of A returns a scalar, which you then multiply by B. That must be what that means, right? Which I don't know what that actually means, but I think that's mathematically what's happening with that. It's more common to say del dot A though. I don't know why they reverse the order. But it should be commutative, right? It doesn't matter which one you put first. Yeah. Lathic and I had a fight and I lost. Screw it, I'll use word. There you go, Jasu. The order does matter? For a dot product? I don't see how. I mean, no, I don't see how. I don't know. I would assume that's still the regular divergence. But del has derivatives, so there's product rule stuff. It matters because of the derivative. Oh. Ooh. Wait. Okay, fine. Complex analysis will be on hold for a little bit more. Okay, if we have A dot del times B, A dot del you're saying we should keep it as like ax times partial if these are 3-dimensional. And so then b would get distributed. But this doesn't make sense to me. Multiply each component of b by that. Oh. Oh my god. So it's ax dbx dx plus ay dby. No. Az dbx dz in the x direction plus the same exact shit with by, and then the same thing with bz. That's crazy. Arush. I'm not sure exactly what the constraint is, but if you got accepted to a really nice institution, it's you probably regret it later in life if you didn't do everything you can to take them up on that. Are you MC Hammer? That shit is too legit to quit. That's a crazy amount of terms. Wow. Graph isomorphisms, VF2 algorithm for force field conversions? That sounds cool. Sounds like something from Star Trek. Wow. Wow. Okay, well, I guess I was assuming you can just kind of sneak the A in there, but I guess there's a difference there. Got a screenshot of it? All right, I'm going to delete it. What does 19 say? Modulus of z from minus I to I over the unit circle in the half plane. Need a physics tutor on call? It is kind of awesome that like Dr. L and Hamiltonian Amps are just able to answer your random question. Like the stream is like basically it's almost that, at least. I mean, you're really good at the physics that like the first and second semester physics classes. You're really good at that. Magnitude of z minus I to I over the unit circle in the right half plane. What the fuck? Sorry, okay. Okay, maybe if we put it in polar coordinates, that'll make this more clear. because theta will go from minus pi over 2 to pi over 2. R is equal to 1. So it's just e to the I theta? Question mark? I think that's what they want. E to the I pi over 2 is I. Oh, this is an independent path, isn't it? Yeah, you know, I wonder if I should just... You're right. It is incorrect to... This equality is not correct, right? I think the answer should just be 2i. Yeah, that's where I'm getting confused. We're like... we're integrating the magnitude of z, but on that... I don't quite understand what the actual contour is, I guess. Am I going directly from minus I to I, or... Well, I guess not. I guess minus I to I are the endpoints. Get rid of that. And the path between those two endpoints is the right half of the unit circle. But is magnitude of z analytic anywhere? Or isn't it analytic everywhere? Because it's just equal to r? Except at 0, maybe. Or even at 0? It's not a closed contour. It definitely doesn't go through any non-analytic points. It involves the conjugate. Oh, that's a fair enough point. Hamiltonian dynamics, yeah. I forgot about that. Magnitude of z is, I guess, root z conjugate. Okay, that sucks. So I assume we're probably not going to be analytic. Yeah. So do we want to split it up into, well, we probably want to split it up into like a real part and imaginary part, multiply it out, and get two different integrals potentially. The book that I'm using gave a technique on dealing with these. Or you can just do it with polar. Oh. Okay. I guess Ooh, you learned in Spanish, Dr. L? Hell yeah. Thanks for hanging out. See you later. Yeah, so we can take z equal to I theta. Because r is 1. C conjugate is e to the minus I theta. dz, don't forget this, like I do every single time, is I e to the I theta d theta. These are 1. Ooh, forgot the I. So I to the I theta d theta. So we're just going to divide an I out. So it's e to the I theta. So it does end up being the exact same thing that I said what's going to end up being, I think. Maybe, no, the thing I said would have had to divided by I there, maybe. It's going to be I minus negative I, so 2I. Let's fact check that answer. Yep, 19 is 2I. Oh yeah, I should have said adios. Would have been much more fitting. Number 21, e to the 2z. Why are you saying it's analytic? I think as soon as z conjugate is involved, the function is almost always, or maybe even just always, non-analytic. The straight line distance is also 2I. That's a fair point. If the result of the integral is analytic, it is independent of path. That we learned that in 2.4, I think. That was like one of the first things the book talked about. Let me find it. I need to, where do I keep this book? So if the result of the integral is analytic, oh, yeah, then you're independent of path. I think that's the rationale. I'm not 100% certain. E to the 2z from 14 plus 3 pi I to 14 minus 3 pi I along any path. Well, e to the 2z is analytic. So we can just, and the integral is certainly going to be analytic, so we can just take the endpoints. Fourteen plus 3i, or 14 plus 3 pi I to 14 minus pi I. Okay. The straight line distance is not the integral of the modulus of z. That is the straight line distance from minus I to I, right? Is that just a coincidence then? That's just the integral of 1. Okay. From 1 to 0 and back to 1 along that line segment. I don't know. Do not know. Oh, along the straight line segment would not be 2i. Because in that case, we would have the integral of r dr. Like we'd take z equal to r. And r would range from minus 1 to 1? Z equals ri. And then, so you just get minus r, or iy. Oh yeah, iy is maybe a bit more clear. I have a letter to use here. I'm saying it's minus y because dz equals I dy. So we'd actually get negative 2 here, right? I don't know if that makes sense or not, but I'm getting 0. Am I supposed to get 0? Absolute value of y. Maybe. Yeah, if it is modulus z, I guess. Hey, wait, did I just say hi to you, Akari? I can't remember. If I didn't say hi, then hi. Try to prove a theorem. What theorem? I want to check the answer to 21. I feel weird that I got 0. Oh, it is 0. Okay. I guess it's just a coincidence. Because they're separated by 2 pi, maybe? Or 4 pi? I don't know. 23. Z conjugate over mod Z, counterclockwise. See, now this one, the Z conjugates might cancel. Counterclockwise around mod Z equals 4. What number was this? 23? Oh, wait, no, there's a square root. They don't cancel. Akari, if you're going to try applying natural numbers to the interval between 0 and 1, I think you're going to have a bad time. Well, so the natural numbers are always countable. The real numbers between 0 and 1 are uncountable. How many sequences can you prove between two numbers if added in higher and lower frequencies would give out 1? Uncountably many. How many pairs of numbers between 0, how many real numbers between 0 and 1 add to 1? You're going to get uncountably many. Hey, Viv. It's been good. I went to the boardwalk with some friends last night and had a very good time. Yeah, other than that, just kind of calm. I'm not sure what that really means, Ikari. Put it in like an ordered sequence and fit it in a definite function like gamma. I'm already not the best with this stuff in the first place, but I'm not really sure like what you have in mind there. Okay, if I go to my beloved polar form, if z equals re to the I theta, the modulus of z is equal to r. Z conjugate is re to the minus I theta in dz. Oh wait, isn't it's always 4. Let me just go to 4. For I e to the I theta d theta. Here 39? No, Santa Cruz. So like they have a bunch like it's like an amusement park. Like they got like a roller coasters, oh, I forgot to talk about that. The thing where you stand, like the circular thing that spins around and you're standing up and you get like pressed back into the wall. the entire time I was on that thing, I was just thinking about like relativity. Like, is it like is that what gravity actually is? Wait. Uh, this is just gonna be 2 pi I, isn't it? Very close to your alma mater. Oh, I I mean, I don't know if you want me to say it, but I can think of a school that's like right there. 4e to the minus I theta over 4i e to the I theta d theta. About an hour. Oh, okay. Then I take my guess back. I think I meant UCSC. Ikari, I'm solving I'm learning about contour integration in complex analysis. And so I'm just trying to drill some integrals here to learn it better. So actually 8 pi I? Can we fact check this? What is that, 23? 2 pi I? Bleh. Oh, yes, Starbucks, I see your note. You also got 8 pi I. See, I guess 2 pi I because like the modulus of z conjugate is 4 and we're dividing out that 4. It feels like we really are just integrating around the unit circle because like conjugating it doesn't really change anything either. So I feel like 2 pi makes intuitive sense. I don't know why I can't squeeze out that answer though. These problems in 2013. Oh, wow, okay. Um, I see you have a question mark by that one. So what's wrong with this? You bet we got it right and there's a mistake in the answer. Ooh. Well, let's go to Google then. Hmm. I really wish that Wolfram Alpha. Oh man, what does Google get? Google AI gets 8 pi I in case anyone needs some toilet paper. Okay, if I can solve this a second way and still get 8 pi I would feel satisfied that there's a mistake. Oh, it got all stretchy. Did I figure out the source of the stretchy? Wait. Oh, I figured out why it goes stretchy. I've been wondering that for so long. It's because I'm clicked into my OBS and I'm hitting the buttons on my tablet. And so it's just doing strange stuff. Google AI sucks with math. Yeah, I know. I don't trust it. You hear toilet paper? I mean, if you're not talking about weird stuff, what are you really talking about? I was saying that I was looking at the answer that Google AI got to a math problem just out of curiosity. I really don't trust it as far as I can throw it though, so the mouse is indeed here. Scream for the mouse? What? It's not closed. Wait, yes, it is closed. I don't know if this is written like I'm concerned that I shouldn't call this a contour integral still. If you don't like it, sue me though. Oh, thank you. Thank you, thank you, thank you, thank you, thank you. Hey, Carboy. Oh yeah, Viv has been known to rick some rolls. Okay, so what I want to do is split this up into real and imaginary components. What's the best way of doing that? So we have an x dx and a y dy. For the real part. For the imaginary part, we have a minus I y over x squared plus. Well, this doesn't make sense. What I'm writing here doesn't make any sense. Well, x squared plus y squared is a constant, right? Can we just say that's always 16? Like, or even at this stage, just say this is always. Oh wait, I messed this up. That's a square root. Yeah, okay. I want to back up. Yeah. Let's just say this is always 4. I'm still not sure if this is the right like symbol to use here once I do the change of variables, but I don't know what else to call it at this stage, so. Square root z bar z, I think. Evidently, I always get that mixed up. Oh, hey, our Pete. I'm saying that right. Sorry that I didn't see you immediately. Z conjugate of Z bar Z? I feel like you... Yeah, Z bar Z is Z squared, okay. Do magic and cut the bar Z? You would, but because you'd have to substitute square root Z bar, so it doesn't give you the nice cancellation. Femvox, on the circle since around the origin, x dx plus y dy is 0. Probably? Is it because x and y are ranging over the same thing? Or I don't quite know how to interpret this yet. What's going inside the imaginary integral? We have an x dy. We have a minus y dx. X squared plus y squared equals c, then just take d of both sides. Oh. Okay. Good night, mouse. That's my problem too, Femvox. I'm kind of a quiet person. You are not quiet, mouse. don't try to tell me that you're quiet. Okay, you become chatty lately. I can accept that. You'll do it if I do. Oh my god. Used to own a bar. People forcing. Oh, dude, that's awesome. You used to own a bar. Our owners are well known for their quiet demeanor. Is there like a Green's theorem thing we can do to mess with that? This feels very Green's theorem. Where does the book introduce Green's theorem? Is it seriously in 2.5? Oh, it is. Oh, so I guess it is correct to keep that contour integral symbol. What am I doing again? Oh, yeah, okay, we're integrating around modules of z equals 4. Uh, aren't we just getting 0? If I apply Green's theorem? No, 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 no. There's a negative involved. Okay. Yeah, let's try to apply Green's theorem. I just need to... let me screenshot it. Let me greenshot it. Okay. 1/4 I. Double integral. A double integral in regular Euclidean space feels so, like, pedestrian now. Okay. V is the part that goes with Y. Oh, wait. No, this is zeroing out. Green. Am I stupid? Wait, V is the part that goes with Y. Oh, I wrote it backwards. That's why. Okay. So that's 1. U is the part that goes with X, which is minus Y. So that's -1. So we get 2 dx dy. And then what are the bounds? We're trying to capture the unit circle, or no, the times 4, which is annoying to do in Cartesian coordinates. So should we transfer, without even trying to figure out the bounds here, should we just make it polar coordinates? Take the 2 out. Oh, yeah, duh, Hamiltonian. Whatever you're paid, you deserve a raise. Just forget about what the integral actually means. Why don't I? I don't think I'm getting the right answer here, though. Wait, so the area of a circle is pi r squared. Oh, wait, maybe I am. Well, I'm getting the negative, which isn't good, but... It's pi r squared, so it's times 16 pi. So I'm getting -8 pi I. I messed up a sign somewhere. Oh, I didn't mess up a sign. I just wrote the I in the wrong place. Okay. We did it 2 different ways. We got 8 pi I. I'm saying the book is wrong. CWH, yeah. What's your question? Number 25. Z to the -2 tan Z clockwise around any contour enclosing 0. Yeah, you can type it there if you want. Confirm your solution. Only have to wait 12 years. No problem. In another 12 years, I'll answer the little question you wrote in there. All right, see ya, Hamiltonian Dynamics. Thanks so much for all your help today. That is a good question. I assume we wouldn't want to enclose those other points. It's been a while since I've gotten a bot like that. I mean, I guess I'll hide the YouTube chat for a minute. I really don't care about that one, though. Integrate secant to the power of 5x. Oh god. Maybe that one won't be too bad. So when there's an odd power, these integrals are sometimes not as mean as they could be. Too hot to handle, it really is. So the thing to think about with these problems are the Pythagorean identities, because usually if a Pythagorean identity works, that's the easiest thing to use. So if I know this, we can find the one involving secant by dividing each side through by cosine. So we get tangent squared plus 1 equals secant squared x. Oh no, I don't think this will work out. No, I think maybe for secant you want the even power. That's the easy one. So yeah, actually, because I know secant cubed is a actually CWH. I should ask you: is this? Are you just asking me a problem to challenge me right now, or like are you like is this like your homework that you have to actually solve? Because I've definitely done secant cubed before, and that's not an easy integral. I imagine secant to the 5th is much meaner. Okay. So yeah, it sounds like you already know the the technique to solve it. I really would rather not waste like an hour of my life doing this. Yeah, I'm not doing this. The DI method, I guess, is probably the way to go. Because what would you do? You would pull out. I guess you would want to integrate secant squared, and then you would take the derivative of secant cubed. Oh, Wolfram Alpha cuts off more the. Did they nerf how much they show you? They used to show you like the first 2 steps or something. And I could abuse that by I take whatever their next step was and plug it back into Wolfram. And get basically the step-by-step solution for free. Oh, do you not know Wolfram Alpha? If you don't know Wolfram Alpha, you should, because it can solve basically any question from like the first 2 semesters of a calculus class. Phobos, hey! Reduction of order formula. Okay. I forgot about those. Can I bring up the chat back? We're not fingering ourselves anymore. Oh wait, that's the wrong chat. That chat. Okay, yeah, we're good. I can solve easy physics questions. My physics isn't that strong, CWH. Looks like an awful integral to do by hand. Yeah, Cytos, it does. More students learn the algorithms finding the antiderivatives and to actually do them by hand. Yeah. With odd powers of secant, it gets more interesting to learn the algorithms very quickly. Oh, you know what? What's even better than Wolfram Alpha for integrals? Usually it's not quite as powerful in terms of the number of integrals it can do. The integral calculator. It's completely free, unlike Wolfram. And it will give us every painful step of this integral. So yeah, they're using the power reduction formula. The website does make me laugh with how the dude's face like follows you around as you scroll around. Like I just can't run away. Wolfram's in it for the money. Integral calculus steps in it is in it for the attention. I mean, honestly, I really respect that this is just out there. Pick to be reserved for the smartest or the fittest. Cheating is the gift the man gives himself. So the critical eye will use the site to cheat on your math homework. He is. Integral of root x squared plus a squared. Probably. That's a much shorter question, at least. So thank you for doing me a favor in that respect. Why cheat on your math homework when you can just not do it? Cytos, you think big, and I appreciate that. Yeah, so for this one, you're going to want a tangent sub. U is going to be a tan x. Du is a secant squared. Nope, no, I reversed it. X is a tan u. Sometimes they use theta for these subs. It's all the same. X squared is a squared tan squared plus a squared times a secant squared u du. I've seen that. Yeah, that's like a computer science thing for a tan, right? And there's also like a tan 2 that I think is arctan in a different quadrant or something. Okay, so I'm going to take this a outside the integral. I'm also going to factor in a squared from the inside and bring it all the way outside, and it gets square rooted. So we have an a squared on the outside. Root tan squared u plus 1 secant squared u du. And now we need to go deeper with the subs. We need a second level of subs. Someone called Leonardo DiCaprio. We should notice that the derivative of tangent is secant squared. And so what letter do I want to use here? I guess V, because it's the most confusing one to use alongside U. I'm going to take V equal to tangent U. dV is... Oh my god, Cytos, thank you. I'm stupid. I forgot. This is the Pythagorean identity. Oh, CWH, did you trick me? This is secant. So yeah, you end up with the integral of secant cubed. And I'm not doing this one either. Because it's annoying. It's hilarious out of context. I need more subs. Give me all the subs. What a good sub. I like how it can be interpreted as both like a sub sandwich, but also a submissive. There's multiple layers of jokes happening here. And a subscriber, true. Wait, how do you read sub, Jasu? Because when you say it's hilarious out of context, my mind goes to submissive. Um, Yeah, don't worry about it, CWH. I was gonna put that there because half the time when someone brings up JE, like an argument starts, and I don't know why. So I just kind of stopped wanting to deal with it. Okay, yeah, no, that's what I was thinking too. I don't know what Jasu meant though. All right, fine. We'll do integration by parts. Oh, I hate doing integration by parts when I already use U though. Ugh. Okay, what am I gonna use instead? W? It is twice as good as U, W. W will be secant U. dV will be secant squared. Why not triple U? That's true. Ugh. Derivative secant is secant tangent. So V is tangent U. Then UV, V to U. Oh, that's confusing. WV. Whatever. Be like Zach. I know. I was just thinking of Zach with his funny variable names and function names. I don't know how you pronounce that character. Dude, that's like a hard one. It would take me so long to complete a problem using that as a variable. I'd be so worried about drawing it right. I'm not even gonna try to draw it. How do you integrate that? Oh, it's one of those circular ones, isn't it? Um, you do the Pythagorean identity. That's why this thing becomes a pain. Oh no, but the a squared. Oh no, it's okay. It's okay. The a squared is fine. Tangent is secant minus one. And so this is one of those tricky integration by parts where you have to notice there's a secant cubed here. And we have to remember that we started with a squared integral secant cubed. So we can add this entire thing to the other side and then divide by 2. So we get a squared over 2 secant u tan u plus a squared over 2. The integral of secant is probably another integration by parts if you want to actually show that by hand. Or if you are a math streamer and you have chat just give you the answer, you can know it's that. I think if I tried harder, I could have remembered that because that looks like the derivative of secant with like secant derives to secant x tangent x, and the integral is ln secant plus tangent. Oh, you're right. Hi. We do have to back substitute. But yeah, Phobos is really good at coding. We were trying to get her in on the last competition. I think the scheduling didn't work out though. If x was a tangent u, then u is arctan x over a. Yeah, if I was betting on a coding competition with Phobos involved, my money would definitely be on Phobos. But it would also be a very good time. I was gonna say that tangent of arctan is x over a because I'm running out of room on the line. I think tangent of arctan is the good one. Like it is a thing that tan of arctan isn't always arctan of tan. I think this is the good direction though. I don't remember that. I don't remember exactly, but I think for this problem we don't have to worry too much about it. Okay, yeah, that's what I was thinking too, Cytos. For secant of arctan, we got to draw a triangle though. Osman. We probably figured that one out. So let me finish up this one. What, Lucas? Arctan opposite over opposite over adjacent. Secant of this is hypotenuse over adjacent. Sounds good, Osman. I'm nearly at the end of this one here. Okay, just cleaning things up now. We're gonna get 1/2 x root x squared plus a squared plus a squared over 2 ln. Oh, we can be kind of tricky here. We can get a common denominator for this fraction. So I'm going to write what the result is going to be. X squared plus a squared plus x. And using log identities, we can say it's minus ln a. But we can just absorb, the ln a is just a constant. So we can say that c is going to include the minus ln a and just kind of erase it from the problem. So I'd say that's what the answer is. You sure were cooking there, Lucas. I don't know what you were cooking, but you were cooking. Properties, what exactly integrals do? That's kind of open-ended. I'm not sure where to take that one, Lucas. Either way, I want to get to Osman's question because that one came first. Not right now? Okay. Yeah, I guess that's kind of like the open-ended. Just to be clear, f of x, y, z, or f of x, I guess, is x squared 0, 0. Flux of the vector field through the part of the plane with equation. Okay. Interesting. So first off, to figure out like if they're asking us to do it in the first octant of the plane, or yeah, the first octant of 3D space, I bet the plane just has a little like triangle that's in the first octant here, like something like that, so it's finite. Otherwise, we're just going to get infinite flux, or maybe zero flux if they're exactly in line, but they're probably not in line. um, and actually, we can know that for certain by, like, if y and z are both 0, we know that one point on the plane is x equals 1. So, like, we know that 1, 0, 0 is one of the points on the triangle. And we do the same for y and z. So, like, 0, 2, 0 is another point, and then 0, 0, 3 is another point. So actually, I didn't draw this triangle half bad. A vector field of x squared means that all our flow arrows are going in the x direction everywhere in space. I need to look up, like, how do we actually want to solve this? My vector calculus, like, it's not the best, so I gotta look stuff up sometimes. So we do have a constant normal vector, which is nice, because it's a plane. Yeah, it's always the mechanics of doing these that kind of trips me up. I understand intuitively what it is. Oh yeah, you can always get your normal vector by gradient of f divided by the magnitude. Why do they do the negative gradient? Oh wait, no, it's not quite the gradient. No, sorry, the gradient is tangent, not normal. I'm not quite sure why they're doing that piece. That's not the piece I'm interested in. I'm interested in how they deal with the ds. The normal vector, I think, is pretty easy to find. They say ds is... epsilon, I probably can't do that, I'm sorry. Gradient is normal to the surface? I'm pretty sure the gradients, it helps you form the tangent plane. It points in the steepest ascent. You can probably use it to get a normal vector. Whenever element involves a fractional part thing, epsilon, I kind of assume I can't do it. That looks like a challenge question. That's not really a normal limit that you have to do in a calculus class. What's the question, Vishal? Um, Dude, the only thing I don't get is what is a DS? Maybe I don't want to look at Paul's explanation for this. You don't actually do a problem. Magnitude of the cross product of the two parameters. I guess that's what it seemed like was happening. Vishal, I can't really do JE Advanced, I'm sorry. You know what, let me go back to Paul. I think I should just read it closer. What's the parameterization that we need to choose? CWH, you don't need to be so rude about it. Vishal, I'm sorry. I've tried J advanced questions but before, and they're just a little bit too much for me. I feel like we could just skip, like, I want to say just the magnitude of the normal vector. In our case, because like a plane is a really simple normal vector. Don't like quote me on this, but like, it's not yet, but well, how are we parameterizing this? Like, I want the inside of the integral at least to be something like, the normal vector for a plane is just those coefficients, so 6, 3, and 2. But then it's just like the little ds part. Well, I guess this needs to be normalized, is the issue. Opposite of the flux. Ooh, that's an interesting thought. It might. That's almost getting at like a Stokes theorem idea, I feel like, which we might honestly be able to do here too. Points of inflection, we can talk about them after, yeah. God damn it, I just need to remember how this RU cross RV looks. I'm sorry that I'm not gonna. I'm sorry that I'm like struggling with this sort right now, Osmond. I just haven't had to actually calculate one of these by hand for a while. Where does he actually introduce this? Okay, here. Trig problems, yeah. I'm probably not going to stream for much longer today. Like, I'm starting to get tired, but okay, can we parameterize a plane by taking just like two vectors inside of the plane and doing the appropriate, like, or figuring out like how far to take those vectors with the ranges of u and v? Oh, hey. Okay, that's not too bad. Three over 35? Okay. So, okay. So with the plane, if I'm probably gonna explain this terribly. For the parameterization of the plane, I'm just gonna say y is equal to u, z is equal to v, and that means that 6x plus 3u plus 2z, oops, sorry, plus 2v is equal to 6, so we can just isolate x here. 1 minus a half u plus minus a half third v. So the parameterization be 1 minus a half u minus a third v u v. Okay. Now that we have that, we need partial derivatives, it looks like, and we need to cross them. Suki 1 plus 1 equals 3. It sure does. Three because without a condom. Exactly. Sine 3a. I don't know how you derive that formula. CWH, I'm sorry. Okay, so then are you... Hope you're doing well, Kazuki. Always good to see ya. negative a third, 0, 1. Okay. And we're gonna need the magnitude of this thing. Or well, let's just get the cross product. The smart stream. I mean, I'm kind of like stumbling really stumbling through this question, but I don't feel very smart right now. I think I'm getting through it. Okay, I bet you could do this way simpler just by thinking about what this means, but this is sort of at the edge of my knowledge, so I'm kind of doing it the slow way here. The important thing is that you look smart. Yeah. Express vector field in terms of u and v. Yeah, we're gonna need to do that. Oh man, we're gonna have to square that. It's a little bit annoying, but we can do it. These should be hats. Okay, so that's I hat plus a half j hat plus a third k hat. Okay. Presses marker into a number on the whiteboard to assert authority. Not agree and shout some random numbers so they scared and think I'm right. That's the way to do it, Kazuki. The more aggressively you say that you're right, the less people will contest you. Okay. Yeah, we should also normalize that. I guess, yeah, we can do that now. Let's just get the magnitude separately. Triple integral. Actually, the answer is purple. Triple integral. So you have no confidence. Okay. So did you use Stokes' theorem then? Oh, I think you can just dot it. The answer is 1/2, apparently. Okay, that's good to know. Okay, so if we need to parameterize, we need to get f in the same parameters. So x squared. This is the part that's going to be a bit of a pain. A third v squared. Okay, so we need to square that thing. Do we have to? Can we avoid doing that? I'm just kind of realizing that now. I don't know how we're going to set up the bounds for the area. It'll be fine. Medin 2? I don't think I've heard of Medin. You know, let's just not square this right now if we don't have to. So it's going to be f. I might just use Wolfram to square it because I feel like I'm going to make a mistake if I do it by hand. Dot with 1/2, 1/3 And this is where we have to parameterize things with u and v, or we have to figure out the bounds for u and v. So I would assume if y equals u, the farthest out y goes is the point 2. So I think y goes from 0 to 2, or u goes from 0 to 2. Because I'm basically thinking about I was coming from the origin out to the like corner of that triangle where x and z both equal 0. I hope this is going to get us the right answer. And then if z equals v, the farthest out z goes is 3. So I think v is going to be 0 to 3. I'm from America, Vishal. Ooh, the red lights. Roxanne. Oh, so Osman, this was completely arbitrary. We just needed to get a parameterization of some kind. So I just kind of randomly chose y equals u, z equals v. There's infinitely many right answers here, though. So you can kind of, to parameterize a plane, you can take any two variables you want, just equal to 2 parameters, and then figure out what the third one has to be. With different permutations, you will get different bounds. I think for the one that I chose here, that's the one that we get. Yeah, so I think there probably is a better one. I did not go to MIT, no. Definitely not. Yeah, okay, so the good news is about the vector field, these second two components are 0. So we don't have to care about those two components. So we do the x times the x, but that's just 1. I'm going to make Wolfram Alpha square that for me because it's getting towards the end of the stream and I feel like I'm going to make a mistake. My brain can only handle so much math. There we go. You know, we can even just put that right there. My handwriting is just super neat. Don't worry about it. Okay. Now we can actually integrate this bad boy. So we're integrating with respect to u first. That's another arbitrary choice. Wait. Oh, sorry if that made a noise in the mic. I think we're okay. Oh, Phobos, I was just debating that exact thing. I'm not actually sure now. That's why I scrolled up to my parameterization. Oh, nice, Vishal. I know, Fenlux. I think if this was a physics question, they would figure it out some intuitive way. That's like 3 sentences. You raise a good point, Phobos. How do we figure that out? So yeah, Osmond, what Phobos is asking is like, shouldn't this 2 actually be a function in terms of v? Because otherwise we are just kind of integrating over a rectangle. How do we actually find... Draw a funny face on it too? I mean, I made my little picture right there. So we want u to range from 0 to 2. When u equals 2, what does v equal? Can we think about it like that? Well, no, because we have like that third variable there. It might just be a calculus question because it's x squared. And so the plane does vary with x. So it might just not be, you might just need to do some type of calculus like this. Vishal, I'm not interested in an argument about this. This looks nothing like the JE advanced problems that I've seen. Hey, S. When v is 0, u can range to 2. The thing that I'm confused, that I get confused about is like what happens with x, or like it doesn't feel like, it just doesn't feel clean for some reason. Like, or I feel like I have too many variables. Yeah, I mean, ChatGPT can't always be trusted for stuff like that. Like, even if it gets the right answer, you don't always know if it did the right steps. So you always need to like think critically if you do. Use ChatGPT. Maybe I am overthinking it, and I should just go with what Phobos is saying. Hey Pablo, when v is 0, if I just take x to also be 0, I guess. We have the point. If I do uv, if u is 0, v can be 3. If v is 0, u can be 2. That makes a line. Oh yeah, that parameterization should also be fine. I wonder if I confused myself with the u and the v thing. That parameterization might be a little bit more intuitive. I think I'm about to get it, though. This is the y-intercept. U is equal to something v plus 3. All right, see you, Phobos. Thank you for your help on this. Oops. Ow! I just stabbed myself with my stylus. Okay. It runs 2, lowers 3. Rise over run. So -3/2. Okay. Let me see if this gets the right answer and I can come back around and explain it. Actually, let me make Wolfram Alpha get the answer for this because I don't know if this is right and I don't want to spend much time doing it by hand. If it's not right. So if it gets to the right answer, I'll explain it, and if not, let's not waste time explaining something that I did wrong. So I'm saying 0 to 3, 0 to -3/2 v plus 3 u v. Oh, oops. It's really bad if you get a non-convergent integral for this. Someone's really gone wrong. Okay, it's not right. Why? Okay, let me try. So I think I do prefer the parameterization that ChatGPT said because that just seems a lot more intuitive. That does mean I have to go back through. I'll make Wolfram Alpha get the cross product and that type of stuff. Because I feel like I'm really confusing myself with the U and the V stuff here. Okay. So we would need R sub x, which is 1, 0, -3. R sub y, 0, 1, -3/2. Okay, Wolfram Alpha cross product that. It should be able to do it, right? I've never done a cross product in Wolfram. I assume it can do them. 1, 0, -3. 0, 1. Nope, it's doing element-wise multiplication. Or no, it's not even doing that. They don't have this built in. Cross. Okay, that's what you need. Okay. Just use that. Zero, 1, -0/2. There we go. 3, 3/2, 1. Okay. Oh wait, so is this parameterization going to be way easier? Did I really shoot myself in the foot by making X the thing that wasn't good? Because now X is just X. I don't have to square crap. So it's gonna end up just being 3x squared inside the integral. Now for the bounds, I do want to go back to Wolfram, because I mean it's still not really that bad, but 3x squared dx dy. Okay, so y we definitely know goes from 0 to 2. And so I think we just kind of don't worry about z, or like to figure out the bounds for x. Like I think we've taken care of the z part with our parameterization. So just let z equal 0, and we'll find 6x in the plane equals 6. And that's going to be the upper bound for x. So we're isolating x here. One minus 1/2 y. One half. Oh my god. Okay. Osman, I'm sorry that that took me so long. If I wasn't as rusty on this, I would have been able to figure that out way faster. Okay, so I don't know how much you were following along with my insane ramblings, but if you want, I can back up and explain this a little bit better, or I don't know how you feel about the problem. Okay, no worries. So CWH, are you still around? Oh yeah, sure. So the first step was to choose a good parameterization. Now you saw why it's important to choose a good parameterization. So the parameterization we chose, we just let x be, or we let x be x, we let y be y, and then z is whatever makes the plane still be true. So we basically just took the equation for the plane and isolated z. I don't think I ever had to actually do flux as part of my degree femvox. I don't remember doing it, at least. And then we find the r sub x, r sub y, do the cross product to find our normal vector. And I think there's probably an interpretation. I should learn why that gives you the thing that you want there, but once you have that cross product vector, we can go to the integral. So we take the original field, dot it with r sub x cross r sub y. We end up with the double integral, just 3x squared dx dy. You could also reverse the order if you want, it doesn't matter. Figuring out the bounds of the integral, y is on the outside, so that's the easy one. We can just simply say that y ranges from 0, the origin, and then this point right here on the y-axis is going to be 2. So the y bounds are easy. X, it'll start at 0, but it kind of, ranges out. Like x starts at 0 and it goes out to the line in the xy plane. So I was thinking that too, Femlux. I just didn't know if it would be the right scale. That's what I was concerned about. Because I don't know how important the scaling of the vector is, and so I just kind of played it safe and didn't use that. But yeah, and so to find the equation of the line in the xy plane, you can take the equation of the plane and let z equal 0, which is what I did right here. And then we're interested in bound for x, so we isolate x in terms of y. Yeah, exactly, Osmond. We would have gotten 6x squared. So I assume there's a way that you can figure that out and deal with it. I just don't exactly know. It probably has to do with our choice of parameterization, where we let x stay the same or something like that. But yeah, so if I had a deeper understanding of this, I'd probably be able to give a better answer, but something to do with the area of the triangle. Oh, true, Fembox. Yeah. I forgot about that. But yeah, the length of the normal vector does scale with the area of the surface. X depends on y. Yeah, for the sake of the bounds, it does. 1 minus 1/2 y. Oh, okay. Well, I'm glad I got a little refresher on calculating flux. I clearly need to do some practice with it. But at least we got there eventually. Okay, so yeah, if you're all good, Osman, let me know, because I think I might just wrap up the stream after this, so. Speak now or forever hold your peace. Oh yeah, I remember that you and Rian are friends. It's exam a few days ago. That's awesome to hear. Love it. Your exam is tomorrow? Oh well good luck then. You got this. The area is 7/2. What is the magnitude of this vector? "36 plus 9 is 45. Plus 4 is 49. 7/2. Haha. That's funny. Awadesh, I don't think I know how to solve that problem, and I need to wrap it up for the day anyway. I've been streaming for a long time. I'm sorry about that, but yeah, I don't think I can help with your question anyway. It looks like a difference of 2 cubes, but it's still not simple, so... sorry about that. I'm gonna close out the YouTube stream here. Twitch, I might just close the Twitch stream too, but I'll try to look for it on Twitch. So people here on YouTube, thanks for being here. I'll be back on YouTube on Tuesday. So goodbye.